Hello, everyone, and welcome. Welcome to today's webinar, which will be a pretty cool demo of the Femap Meshing Toolbox. I'm Jonathan Hill, and before I turn things over to Tommy for the demo, I'm going to take a minute just to give a couple housekeeping notes and a brief intro to ATA. So just to start off, everyone has been muted for now to avoid any background noise or disruptions during the presentation. At the end of the demo, we'll open things up for questions, and at that time, you'll be able to unmute yourself using the button in the bottom left-hand corner. And in addition, you can ask questions to the group or privately to me at any time using the chat, which is also available along the bottom menu bar. And we'll cover all those questions at the end as well. Finally, if you'd like to review today's presentation or share it with your colleagues or anything like that, we'll have a recording of today's demo, and we should have that on our website under the free resources section in the next couple of days. So most of us are probably familiar with ATA either for our robust engineering services or through our role as a Siemens partner and reseller. And really these two go hand in hand. We have experience providing engineering services across a wide variety of industries. And since we're helping solve the same issues as you guys, as our software customers every day, it helps us provide exemplary support. So on the services side of things, our focus is on analysis and test-driven design. ATA is proud to help our customers meet their toughest engineering challenges, whether that means we're performing ground vibration tests on state-of-the-art aircraft, or helping make sure that theme park attractions are safe, or analyzing next-generation spacecraft and planetary rovers. Of course, being experts with Siemens Femap software helps us do just that. And speaking of the software, this is a list of the Siemens product lines that we use and can assist you with. We have a technical support hotline service, which is staffed by experienced engineers who are using these tools every day. And I have the contact info up here on the screen right now. You can either call the hotline or you can send a message through our website. In addition, we can also help with license sales, and we offer a wide variety of classes that range from things like introductions to Femap and FEA to more advanced topics such as dynamic response, super elements, optimization, and more. The full schedule of classes is available on our website. And speaking of our website, here it is. In addition to the full list of upcoming classes and the contact form for the hotline, it also has the latest software product information and brochures, including the Femap 12 brochure that I've shown here. Femap 12 should be coming out pretty soon now, so be on the lookout for that. We also have links for free trials of software like Femap, but my favorite part of the website has to be the growing collection of free resources. These resources include white papers, training videos, tutorials, APIs. There's a ton of stuff out there, and it's all developed by our own engineers, and it's aimed at our customers' needs. After the webinar, I'd invite you to check out those resources, and also let us know if there's a resource that you're looking for. Let us know, and we'd love to look at that. And with that, I think I'll go ahead and hand it over to Tommy for our feature presentation.
Cool. Thank you, Jonathan, and thanks for coming, everyone. Here's a brief outline of our topic today for the Femap Meshing Toolbox. I'll go over how to clean up solid geometry, edit features such as holes, create surfaces from the solid geometry, prep surfaces for meshing, and then mesh them with 2D quad elements, evaluate the surface mesh quality using nastring quality criteria, and then fine-tune the mesh as needed. So I'll go ahead and jump into Femap now. So here's just an example geometry part. I imported this from a Parasolid file. It has some interesting features like these ribs, fillets, holes, and curved surfaces and pockets. So before I get into the Meshing Toolbox, I want to show a couple useful general Femap features. So up here we have our custom tools bar, a lot of useful macros that come available with Femap. They do a lot of things that could be helpful and speed up your process. And then, as Jonathan mentioned, ATA also writes a lot of these macros as well. And those can be found from our website. But I'll start with one of the built-in Femap macros here, the view color swap, which will just give you a nice plain white background really easily without having to click several extra buttons. Another nice feature, if you go to File, Preferences here, this has a lot of useful settings. So for example, the custom tools and user tools, these are the file paths, so you can update that or add or remove files and APIs and update the file structure. Under user interface, you can control here the mouse interface is helpful to dynamic zoom and dynamic rotate around cursor location, and then the reverse mouse wheel direction is useful for maneuvering within Femap as you please. Then view F6 options just has a lot of different parameters to help you visualize Femap as you want to. So then I'll go ahead and get started now with the meshing part. So if you go into this geometry solid cleanup, this is a good kind of a first step into cleaning up your geometry. It's a good diagnostic tool. We can select the part, and essentially what happens is that we have, if you take the default parameters, it'll check the geometry, and then the key here is it'll find any redundant geometry and remove that. So click OK, and we see that this message window, it found 12 redundant points and 6 redundant curves, and remove those, and it passed the check, so we can move on. So that was a good first step. But now here's the meshing toolbox that's here. And a useful tool is the locator. So this is a good way to search for any problematic geometry. So what I'm actually going to go ahead and give this part a simple pet mesh for now. So if I do that, load, just use an aluminum material. Sometimes giving a part a mesh will help you find where the bad elements are. So here's the auto mesh solids box. Okay. So it meshed the part here. We can toggle off nodes for better visibility, and you can toggle off surfaces too if needed. So a useful macro here is the meshing show worst element. So here's what the worst element is, and if you zoom in on this, you can see how it's a solid element, but it looks like a 2D element. So that's usually not a good sign for your mesh quality. So if you go into our locator here, if you go to surfaces, slivers. So here we see we have all these sliver surfaces, and that was the reason why we had that bad element there. So we can create a group of those surfaces, and then go to our feature removal tool. So this command will actually permanently delete any features. We could also have used suppression, which will keep the features, but it will tell the mesh to ignore them. But since we don't want those slivers at all, we'll just go ahead and use the removal tool. Let's go aggressive. And then we can just select that group. So since we have this toggle set to auto remesh, as soon as you update any geometry, the mesh will be updated automatically as well. You can turn that off if you want, but we'll keep that on for today. Then we can do the same thing for curves. So it'll find tiny curves in the geometry, and since they're kind of hard to see, there's this useful tool here, show options, auto rotate, auto zoom, and then click this next button. So that will hop through each of these short curves nicely and zoom in on them so you can see where they are, and then you can zoom out again. So that's what's causing those tiny elements here. You can create a group of those as well. Call those short edges. Okay. And go back to our feature removal tool. Go to curves, aggressive, and select that group we just created. You can see how now it remeshed that, so we have nice clean elements in that region now. So let's go ahead and rerun our meshing show worst element command, and then see what our worst element looks like now. So here it is. So this didn't get detected in our locator command. And that's okay. It's like a little knife edge protrusion here. So we can do something different here. Well, first let's go ahead and delete the mesh for now. Delete mesh, select all. Okay, and then be careful here. It's asking you if you want to delete unused properties materials. Click no here because we want to keep that material we assigned. No, and then so we go to geometry, solid, embed face, that'll isolate that knife edge as its own solid. Okay, let's give it an offset of 1. So we see how we created this extra solid here. We don't need, so we can just go ahead and delete that solid by right-clicking and delete. Okay. So now if we zoom in on this region, we see we have these extra curves that we don't really need. So if you go back to our feature removal tool, curves, but this time, instead of aggressive, let's use combine surfaces. You can just click on these extraneous curves and it'll clean that up nicely and combine those together. So that worked out well. So that covered the cleanup geometry. Now let's go on to the next section, which is editing hole features. So it's really easy in the meshing toolbox to modify holes. So if you go to our feature editing, resize hole, and then find where those holes were. So we have these 3 holes. Oh, and another tip is that we deleted the mesh, so now all these little points are mesh controls. So if you want to hide those, you go to curve, mesh size, uncheck this box. That will get rid of those mesh control symbols. So it's easier to see the geometry now. So going back to the feature editing tool, if you go to resize hole, you can measure the diameter right in here. So if you didn't know what that diameter was, you can find it from toolbox. So there it is, 0.298. Let's say you want to change that to 0.5. It's really easy to click on those holes and resize them. Let's say we wanted to move them or translate them, so we can take a vector. So let's say you want to move them 0.1 in the z direction. Let's hold again, and it'll move them nice and cleanly. So that covers the edit hole feature. Let's move on to creating surfaces from solid geometry next. So let's say instead of a tet mesh, you wanted to create a 2D surface quad mesh. And this part is pretty thin, so it makes sense to model this with 2D elements. So the first thing we'll have to do here is go to geometry and create the surfaces from the solid. So we'll use the surface offset command. There's multiple ways to do it, but we'll use this tool for now. So then we want to select this main surface. So we can either do right click, pick front, or go to the pick here, but that will get us selection for this big surface. Okay, and then Femap will calculate an offset value. We'll accept that value. Okay, and then we'll do the same thing for the ribs. So on each of these ribs, okay. And those will have the offset value entered as well. So there you go. So if we hide our solid geometry, here's the surfaces, and it looks pretty good. There's a couple things we need to do here. For one thing, if you notice, the 2D surface doesn't quite extend far enough to reach the 3D boundary. So we can go to our geometry editing toolbox here, go to extend, then we'll want to keep the curvature continuous, extend to surface, and then let's select this outer boundary of the solid to extend to. So click on one of these, we go to pick, add tangent surfaces, which is really nice. It'll add everything else on that boundary. Let's highlight that so we see that's the surface we want to extend our 2D surface out to. So okay, let's hide our 3D surface, 3D solid, then select the surfaces we want to extend. So we can either go to pick box, or you can just do shift and then drag click. So shift, and then those will get us those outer surfaces. Okay, and then there we go. We see how we have a nice, we get a nice matchup at the boundary with our 3D solid geometry and our new 2D surface. So that looks good. The next thing we want to do is we see these ribs that we created. They're not quite reaching the main surface. There's a gap there. So we can deal with that in a similar way, we can use the extend command, but this time, instead of extend to surface, let's do extend using a distance. And let's use 1, so we click on each of these. And then the one thing to note here is that although this is version of Femap 11.4.2 I'm using, so we have that add tangent surfaces I showed you a couple minutes ago, but unfortunately there's no add tangent curves yet, but I believe Femap 12 will have that feature, so stay tuned for that, and hopefully this will be a little bit quicker and easier in Femap 12. So, okay, and then we can do that for the other 3 grids, so click all those edges. Okay. So these ribs now extend a little bit too far, which is okay. We can use another command called geometry surface non-manifold add. And what this will do is essentially it will create an intersection between the surfaces so that they'll be separate faces. So if we do that, just select all of these surfaces. Okay. And you can change tolerance, but we'll use the default 1e-6 for now. Then, another note is Control G will regenerate the view as well. Okay, so now we have these extra faces. We can just go into that and delete. Delete geometry surface. Okay. So now we have these ribs that are connected to the main surface. So the next step we'll want to do is preparing surfaces for meshing. So you see we have all of these in we have all these pockets in the 3 geometry, and we'll want to project those pocket curves down to the main surface. So one nice trick is to right-click hide surfaces. Then if you go to project curve, imprint, surface to split, we'll just click the main surface here, and then go to dialog select. Let's start with this pocket over here. We can just click on all these curves, and again, this will be easier in Femap 12 once we have the add tangent curves. But for now, we'll just click these one by one. Okay, and then do the same thing over this pocket over here. Get all those curves to project. And now if you hide the 3D, we see how we have these nice curves on our main 3D surface. So we could do the same thing for the ones on this side, all these other curves too, but because of time, I have a lot of things to show, so I'll go ahead and fast forward through that. But let's say that we did all that and we have all of our pocket curves projected down to our surface. So now let's look at these holes. So a nice feature in Femap is pads and washers. So these will create nice regions around holes. It'll basically give you better elements when you go to when it's time to actually mesh the surface. So let's start with pad. Let's add a washer, and then a good default or a good rule of thumb value for pad factor is 2.5. So then you see how we get that nice thing. But the thing is, we want to align that with the rib. So we can do pad alignment tangent to curve, and then select the rib edge. Okay. And now we see how this one's aligned nicely with the rib. And we can also do the washers and pads separately. So you could uncheck washer and do just the pad, or you could just do a washer. So, and then also instead of using a factor, you can use distance, offset distance. So let's say you want to create an offset distance of 0.25 on this last hole here. So what this did basically was we have this distance should be equal to the offset distance, so we can just measure that to make sure. So measure distance between that point, and that's 0.25. So that gives you a couple different ways to control your pads and washers. You can do them together or separately or one at a time, and you can use either a factor, multiplication factor, or offset distance to control how large your pads and washers are. So one other nice technique for preparing a surface for 2D meshing is creating rectangular divisions in your surface. So essentially what that means is that to get a good, nice, even quad mesh, it's helpful to have a lot of rectangular regions. So to do that, we can use a point to edge command. Point to edge. Also do point to point too. That creates some nice rectangle regions here for the mesh. Also do that on our rib, so point edge here. And then you can't do that everywhere. Everywhere you can kind of get a good region, you can take advantage of that, but some areas are not really susceptible to rectangular, but that's okay. So we did about as much as we could. So let's go forward. So let's say we have all of our washers and pads set up like this, and we have our rectangular regions ready to go. We're ready to start meshing. So we're in this next step, meshing surfaces with 2D elements. So here's the mesh surface toolbox. Let's just go ahead and use the defaults for now and see what that gives us. So just select the whole thing. And again, we can toggle off nodes and surfaces to make it easier to see. So here's just a quick mesh we created. So it's pretty coarse. We can check the mesh quality using this surface mesh quality command. So there's two options for a quality source. You can use either Femap or Nastran. Let's use Nastran. That'll give us the criteria values that Nastran solver uses in order to check our mesh quality. So we can turn on the contour. So the green will be good element according to Nastran. Red is the warning element. So we can walk through each of these. We see a couple red elements here. With warp, interior angle min and max, aspect ratio. So we do have some red elements. So let's go back to our taper. So a nice tool here is if you want to fix these elements manually, you can go to mesh locate. And we have a set to attach to surface and dynamic. So we can select, let's start with this surface here. Okay. Then if you zoom in, you can manually click on a node and then drag it in the position to, so there we go. So we can essentially just fix that element by hand by dragging nodes. So then we can save that change. The other place we had that element was up here, so let's do that same command. Okay. Okay, so there we go. You can do the same thing, mesh locate, select this node and then drag it so that we no longer have a bad element, and then save. And then let's say you went too far and you created some extra bad elements, you can always just discard that and try again. It's not going to save your change unless you want to be saved. So we just go back in there and manually select, and there we go. So we can save that. So, and then one other area we had some issues was here. If you go back to our surface quality, that was under interior angle. So these are the angle values that Nastran uses. So the maximum allowable angle is 150 degrees, minimum is 30, and then you can actually change these values if you want. If you want to use a more stringent or more lax settings for angles, you can. But so for the max angle, we had some issues over here. So we can fix that by going into mesh surface, advanced options, map meshing, and then turn off advanced map meshing, and try again. So basically what that did was, because we had advanced map meshing on, it tried to force a map mesh through this region. And the thing is, it's not really a good region to map mesh. We have these corners here, then it gets thinner, and we have these curves, so it's not really good candidate for a map mesh. So we turn that off and that improve that mesh. So that's some of the tools in here. Let's say you wanted to get a finer mesh. So this is pretty coarse. Let's change our mesh size from the default value. It's down to 0.25. And then let's reselect everything. Okay, and now we get nice finer mesh. And if we zoom in on these holes here, we see that we get nice even quad elements around these holes, and that's because we used the washer and pads. So those washer and pads really helped us get a good mesh in those areas. But we do notice that there are some triangles and stuff in some of these rectangular regions, so we can fix that. If you go to F6, view options, under our curve mesh size, we can turn on symbols and count, and let's make those a little larger. Okay, so these numbers represent essentially the number of elements on an edge. So if you look down here, it says 14, 13, 12. So those numbers don't match up. So that's the reason why we have these triangles in here. So if you go turn off mesh sizing in here and go to our mesh sizing dialog. So the default here is we have it set to increase by one element. So if you click on an edge, it'll increase that number by one. Click on that twice, 14, you get all these up to 14. And then now if you go to our mesh surface and do mapped, map, then that will give us nice map mesh here. And then same thing up here, we have 11, we can make that 12, and it gets nice even quad elements, no triangles in these regions. Here we have 73 and 74, so we can increase that, or these both by one. Great, map mesh. There, that looks good. And here we have 27, so 26. Let's decrease this one by one. Decrease that one as well. Those should match up. You do a map mesh. So we can keep going around and doing that. Here we have 6 and 1 plus 2 plus 2 plus 2 is 7. So we have an uneven amount there. So go back to increase. Increase that one, and then there we go. And then the same thing over here. Have we can just map that one, then map that one. That's 6, that's 7. So we'll increase that. There you go. So we get pretty good map meshes wherever we can. It's there. Then here, this is a little bit trickier. You have to count all these elements. So it's 20, 33, 37, 48, 30. So we could do that. We could just count those out and figure out how many elements we need on this edge. So then the 72, 74, so we'll increase these by 2. So now you get a nice map mesh here too. And then one last couple areas are these two here. So that one should be fine. That one as well. And here, this is 74, that's 68. So if you go to our mesh sizing, instead of increase, we can do set 2 and then specify a value. So let's do 74 and make both of these 74. So you get nice map region there. So it looks like everywhere we have rectangular regions, we have nice even map mesh. So it's pretty good. Let's turn off those symbols and count again. Okay, that's a pretty good mesh. And so that essentially concludes our Meshing Toolbox demo. Just a quick recap. We had an imported solid parasolid geometry. We cleaned that up using a variety of methods. We edited some whole features using the feature editing command. We built 2D surfaces from the solid geometry and then prepped those for a good mesh. And we did the actual meshing part. We looked at the mesh quality using a variety of Nastran quality criteria. And then we using that information, we fine-tuned the mesh as needed. And then so we started with something like this, solid geometry. Then we ended up with a nice clean surface mesh that had good element quality. So that concludes the demo. So here's our contact information. Any questions or anything? Let us know.
Yeah, great. Thank you, Tommy. So I've allowed everyone to now unmute themselves. So if you have any questions or comments or anything, we would love to hear them now. So there's a comment in the chat from Jeff asking if the meshing toolbox is documented in the Femap help. I believe it should be in the help. I haven't actually looked for it myself though. So I can take a look there, and Jeff, I can get back to you later this afternoon with that. Great. So unless there are any other last minute questions, thank you guys all for attending today. Thank you, Tommy, for that great demo. It was pretty cool to see. And of course, we're here for all of you guys. If you guys have any questions, if there's anything we can help you out with in the future, don't hesitate to reach out to us and let us know. All right, thanks everyone. I was going to say, so we got another question in the chat from Andrew asking if we could go over the project curves again to show how to select multiple curves at once. Do you still have that model open?
Yeah, I can open that up. So that's a good question. So yeah, here's our model we had for project curve section. And I guess, Jonathan, do you know a way to do that faster? I was under the impression that in the current version of Femap, it was a little bit more tedious to do one by one, but Femap 12 will have the add tangent curves. Do you know of another way to do that faster in 11.4.2?
I think what you did was probably the best. Andrew, I'm not sure if your question was asking about the tangent or if it was just the difference between the select or the select dialog box. So in the meshing toolbox, yeah, select that's highlighted right now. If you click that, that just lets you one at a time on the fly click things. If you do dialog select, then it pulls up the normal select menu. So then you can start selecting multiple curves at once, multiple surfaces and things like that. And then what we've referenced a couple times is Tommy did a add tangent surfaces where we picked one surface and they could add everything tangent to that. In the next version of Femap, which again should be coming out any day now, there's an option to do that on curves too, or edges. So if you have tangent edges, you could select a bunch of tangent edges all at once. So that'll be pretty cool to have as well.
Yeah.
Awesome. Anything else, guys? All right, great. Well, everyone have a great afternoon. Thanks again, Tommy.